Let's get started. Today I'm going to talk a bit about debugging and how we can make that easier. Feel free to ask any questions in the chat during or just shout. And if you want, please keep your camera on so I can see you. So you might recognize this way of debugging. You console log before and are we here and fast to just figure out where or what is executing actually in your code. But hopefully after today, you will not use only this. I have to admit, I quite often still use this way of debugging because it's so instant. But there are better ways. Use a browser or IDE debugger instead. There are tools for this and they are great. So the simplest way of triggering a debug is to add the debugger statement in your code. And that means that whenever your browser or whatever is executing the code encounters this debugger statement, it will stop everything, pause the code, and open the debug window. So let's have a brief look at how that looks. So here I have just a basic JavaScript file. It loops through an array of 5 elements and then logs that element. And you can see here that I've actually added this debugger statement. So in VS Code, you have this run and debug icon in your side menu. If you press that, you will get the debug interface. And since this is just a plain JavaScript file, let's just play this. Have I messed something up? Probably. Let's try that. Right. Of course, this doesn't work. Let's just copy that. Never mind me. Let's remove that file. We'll come to that later. Go away. Let's try that again. Yeah, exactly. This is how it looks normally when you haven't got a launch.json file set up for a demo you will do in a couple of minutes. Then you just press the run and debug. And if this is the first time, VS Code will prompt you to, okay, what do you want to run this with? And since this is just a JavaScript file, just check Node.js. That runs the code in the VS Code terminal. And as you can see here, it stopped. Well, it has stopped. It's that what this yellow line means. So this is VS Code's debugging interface. Most of them look the same, either the Chrome one or the Firefox one. I'm sure WebStorm is also looking sort of like this. But they basically have a list of variables defined in the scope. You often can see the call stack, what called the function you're in at the moment. You get a list of breakpoints. In this case, we only have this one here at the debugger statement. And then on the top right, you have the debug controls, which is sort of the tools you use to step through your code and analyze it further. So let's stop that and go back to the presentation. So these are the controls, and I thought we'd go through these one by one to see what they do. Start with the play button, and that basically continues the running code, because when you reach the breakpoint or a debugger statement, it will pause the execution. So the play button just continues it until it encounters a new breakpoint. So let's see how that looks. Let's just run and debug this again. So as you can see here, we are at the debugger statement, and right above the breakpoint, we can see that we logged the element, and that's what we see down here in the output. We have logged 1 since that's the first element in the array. And when I press play, the code will continue until it reaches the next breakpoint, which in this case is the debugger statement in the next loop. So even though it looks like nothing happened, we can see that 2 has now been logged in the console. And you can do that for each until it terminates in this case. So that's a play button. The next one is something called step over, and this is the most used control in debugging. It basically executes the next line and then steps to the same expression in the current scope, which will become important. So let's go back and look at demo 2. We have the same for loop, but now we have a separate function that squares the index of this and then logs it. So let's start a debugging session in Node. We see our code stopped on the debugger statement. And let's continue. So we're stepping over. I'm pressing up here to the right. It jumps to the next line. And now we can see that we're stopped right before the square method is invoked. We step over again. We get to the next line in the for loop. Remember, stuff is still happening inside the square function. We don't care about that. We stepped over it, so we're still in the same scope. So if we now hover over squared index, we can see that, oh yeah, it's 0 because 0 squared is 0. And that's another strength of the debug. You can always see what your variables are. So if we continue stepping over, we will get up to the for definition. So we increase index by 1. We check if it's less than the length, and then we do another loop. And we can continue doing this, just stepping through our code one by one to see what happens. And down here we can see that we get the squares logged. So most used command, step over. Step into is...
Can I ask a question?
Yes.
When you were stepping over, going through the for loop now, it said stack frame not found. Do you know, in the top left, do you know why it said that?
Yes. So when we're here, oh right, the brief one up there.
Yeah.
I guess that is because we are in the JavaScript somewhere we're outside of the scope where it can track. So I don't think we stayed in that anywhere, right? There we go. Yeah, it's...
Oh, it's just like loading.
Yeah, my guess is just it's loading. It hasn't found the context yet. Okay. I'm not sure how the debugger works in depth on how it halts the node process and so on. I feel like that's a level too deep. Good question though. Right, step into. Steps one level deeper into functions being called. So let's do this again. We step over the debugger statement, and now we are right before the square. And I'm actually interested in what happens inside of that. So I'm gonna step into. And now we're suddenly inside of the square function where that will do stuff. And if we step over that line, we return that and we're back to the calling function. So it's a way of, yeah, just navigating your code structure and actually seeing what you want to see paused. We also have step out of, which is basically the same thing, but in reverse. So it just plays the code, it continues the execution until the current scopes end, and then pauses again as soon as you are in the calling scope. So, for example, when debugging frameworks like Vue or React, as we will see at the end of this presentation, we will use this quite a lot, because it's often that you end up in some weird internal function in the framework, and you just have no idea and don't care. So you just step out until you get back to your code. Really handy. So let's look how that looks. Demo 3. Here I've just extended the square function a bit to be able to have something to step out of. Run and debug in Node. Once again, we are paused at the debugger statement. I'm gonna step over that. I'm gonna step into the square, and then I realize, oh well, the bug obviously can't be in here. This is so simple, I don't actually care about this function. So I'm stepping out, which execute everything that's left, and then returns me to the calling scope and pauses again, where I can continue my debugging session. So that's the controls. Let's move on to breakpoints. So we've already seen the debugger statement, which you just can write in your code and it will stop. But breakpoints can be set directly in the debugger as well. So here I've removed the debugger statement. This is just my real function. But say I'm still interested in this function, I want to break on this. If I hover the leftmost area of the editor, you can see that there are red dots when I hover. So if I press this, I add a breakpoint. So now if I run and debug this, the code will stop at that breakpoint. And then I can continue as before. You can also do this in the browser, which we will see later on. But sometimes you don't want to break something all the time. Let's say you have a loop and it's just some edge case that makes your code break. So you can add conditional breakpoints, which basically is that break here if a certain condition is fulfilled. So let's see how that looks. Once again, for this breakpoint here, then I can, if I right click, this is VS Code, it works sort of the same everywhere. You can edit breakpoint. So I want to check this when element is 3, because then it apparently breaks. Now you can see that the breakpoint has a small equals sign in it, which means that it's a conditional. So now when we run, we will see that we will get 0, 1, and 4, i.e. the first indexes being logged, and then we break. Which is quite handy. And if I press continue now, the code will run until end and exit, since that breakpoint will never occur again. We can also have something called watchers, at least in VS Code. That depends on the debugging environment as well, but most of them have something similar. That's instead of using the, if we start this one, instead of using this this topmost variables, where you can see that, okay, element is 3, squared index is 4, we can see that the array is this, and so on. You can use watchers to just evaluate something continuously, and that also means that you can check for computed properties. So let's open up this, and I can write just a variable. Let's name it element, perhaps, and that will always display what the element is. And here you can see that we get uncaught reference error when we're evaluating the loop, because there's nothing called element at that point. But as soon as we get into the scope, we will see that. You can also do stuff like is element 3 yes, in this case, since we said that the breakpoint was only for when element was 3. And when we get to the next loop, we can see that it's false. So this is basically just instead of doing console logs, you can always have your variables displayed. And on the notion of logging stuff, instead of writing console log to print stuff to the console everywhere, or checking the variables in the scope in the variables checker, or using watchers, you can use log points, and that lets you log whatever you please, but you don't change your source code. So there's no risk of you accidentally committing a bunch of debugging console logs. So here I want to log what squared index is in every loop here. So instead of clicking here, I'm going to right click and add a log point. I want to log squared index is, then VS Code has this bracket notation, squared index. Now we can see that we have an unbound breakpoint. Let's restart this and see what happens. Oh, sorry. All right. So that occurred. The error message we got there, unbound breakpoints, is where the debugger cannot attach to the source code. And in this case, this was because we've started the debugging in demo 4. So demo 5.js was not known to the debugger. So then we couldn't create this log message. But now we can. So let's run and debug this in Node. And here we get an error. Squared index is not defined. How come? Squared index remove, perhaps I have to say it here. Squared index. Let's try that. Yeah, for some reason it didn't work by just putting it on the blank line. I think that's because breakpoints will attach to the nearest following statement, and in this case it would be sort of the end bracket or even after this, and their squared index won't be defined. So that's probably what happened. But now we log that just before this is assigned. So we get undefined 0, 1, 4, 9. Which can be handy if you don't want to write console log everywhere. Or just write console log everywhere. That's what I do, to be fair. But the option is here. Right, so now you know sort of how debugging works, but we're not usually writing just plain JavaScript files and running them in isolation. We mostly use front-end frameworks and do client-side JavaScripts. So you can do this either in the browser or in the editor. For VS Code, you need a launch.json to sort of tell VS Code what to do in the debugging, sort of how to attach the debugger in the editor to your actually running code. And most frameworks have documentation on how these should look. But let's look at a simple Vue app. So in this Vue debugging demo folder here, let's close some old demos to make room. This is basically just a Vite Vue scaffolding app. We have one app.vue container which displays a variable from the state, and then it has a button that updates the state. I have this running in my terminal already. So just to give you an idea how it looks, it doesn't look like this. This is just the Firefox debugger menu. Let's look at that in localhost 4000. So here's our nice looking Vue app. My var is hello world, and if I update it, it will become hello world 2. But I want to debug this. So as you can see in my code, I have a debugger here. That did nothing here, and that's because I didn't have DevTools open. Basically, opening DevTools is the same as run and debug in VS Code. It attaches the debugger to the current context. So now that I press this will hopefully pause. Yes. So now we're in the browser DevTools debugger instead. You have your controls that we've spoken about down here. Play, step over, step into, step out of. Same commands, different logos or icons. But you can do the same. You can step over, and here, if you have a look here, we can see that my debugger is in a Vue watcher where I have new val and old val, and I can just hover over them to see what they are. They are also neatly printed right beside my function, and you can also see them in the variable view to the right. So this is great to sort of get an overview of, okay, this watcher doesn't do what I think it's doing, but what values are getting into it, and so on. And this, if you look at the sources folder here, this is where you will find your source code, hopefully. And this depends on, since the Vue app is run through TypeScript transpilation and packing with Vite and so on. This is not actually how the code looks like when it's running, but mostly it works that they are mapped, and you can see that anyway. Let's do the same thing, but in the browser. In the IDE. Same code, but let's... and now I will remember to run and debug. Now I need to create a large JSON file because we're in Vue, so now we're not contained in a single JavaScript file. So I'm going to create one, whatever, and then I'm going to paste the one I deleted before. So this I've gotten by just Googling launch JSON VS Code debug Vue, sort of. What this is doing is I'm pointing to the folder where my source code is in my editor. I'm also saying what URL it's hosted against. And this will also launch Chrome at the same time. So if I press, all right, save that, go to app, start debugging. Now Chrome, and you don't see that because I'm not sharing that window, so I will add that here. you can see Chrome now. Cool. So as soon as I press this, our debugger should trigger, which it does, and I'm immediately thrown back to my editor, and I get the same controls as we saw before when running only one JavaScript file. So here I can hover over new val and old val and do everything I did before, but now in my editor. I can step over and step over, and as you see, now we're in Vue somewhere. We're in Runtime Core ESM Bundler. When you get to this, you can try to step out. You will probably be stuck in yeah, we stepped out of it completely and now we're back. Now our code is running again. And if I press that, we are, yeah. If you get into this state, it's better just reloading because getting into debugging yourself your way out of Vue internals is a mess. That's how you can hook up your front-end code to the debugger. And instead of adding this debugger statement in the source code, like we did here, if we remove that and go back to our lovely web page, if we go to debugger and sources, I think it's called only sources directly in Chrome, so that your mileage may vary. Then you can sort of navigate yourself, localhost, source, and there's the app. View file, and we can add a breakpoint, just as we did in the editor, and which should trigger when I press the button. Yes, exactly. It's a bit of a mess to navigate sometimes. As you see in this case, I've got two app view files. One is the minified version, it seems like, and one is the mapped version for the original. Sometimes you can find stuff in the vit folder. Yeah, just try to navigate around, but adding a debugger statement in the code always works. And that's all I have, a brief overview of debugging in the browser and the IDE. So thank you for listening. Here are some resources, the VS Code debugging docs, and you can find these slides at per.fyi/talks. Thank you.